Example 3. A projectile is fired with an initial velocity of 180 meters per second off the edge of a building. We want to determine the range from the building to where it strikes the ground. So we're looking for this range in here between the building to where it hits the ground. So we're looking for that distance. So I don't have to sketch this. I'm just going to kind of draw on top of the picture here. So I'm going to put in the x-axis and the y-axis. And we already have point A, that's where the projectile is being fired, and we have point B here where it hits the ground. Now notice we don't have an angle for this problem. Instead we have a slope triangle. That's something we did see in statics, so I'll review that. So the first thing I'm going to do is start with an equation here. So we want to find the range, right? This is what we're after, x sub b, right? I can't quite use this formula yet though, because I do not have time t. So I have everything I need except for t right now. So I'm going to go ahead and use one of the equations in the y direction to figure out what t is, and then I'll come back and plug it into this equation here. So I'm going to use y sub b equals y sub a plus the initial velocity in the y direction times t plus 1/2 times a sub y, acceleration in the y direction, times t squared. Right, so I'm going to use this formula because it will allow me to solve for t. And that's the time it takes for the projectile to go from point A to point B. Y sub b is the height of the projectile when it's at B, which is just 0. Y sub a is the initial height, which is 100 because that's how tall the building is. And then I need the velocity, the initial velocity in the y direction. And this is where that slope triangle is going to come into play. So I'm going to do some scratch work on the side. Let me go ahead and make a note. So we have this initial velocity, that's 180, which can then be broken down into its components. So we have the initial velocity in the x direction and the initial velocity in the y direction. And then we have this little slope triangle. So this is 4, 3, and then this part here is 5. Then we're going to set up a proportion. So the initial velocity in the direction of y, I'm going to put that over 180, the initial velocity. So I'm taking this side here, putting it over this length, and I'm going to compare that to 3 over 5. And then just solve for the initial velocity in the y direction, and that's going to give us 180 times 3/5, which is equal to 108. So I'm going to put 108 here, t, plus 1/2 times negative 9.81 times t squared. And then you can use quadratic formula to go ahead and solve for time t. So obviously I'm going to use the positive value that I get, which is 22.91 seconds. So that's how long it takes for the projectile to get from point A to point B. So then we can go back to this equation here. So we're looking for the range. So x sub b is equal to x sub a, which is just 0. And then I need the velocity in the initial velocity in the x direction. So I'm going to have to use that slope triangle again. So I'm going to do a proportion like I did earlier. So the initial velocity in the x direction, I'm going to put that over the initial velocity. So I'm taking this side, putting over this, and I'm going to set that equal to 4 over 5. So the initial velocity in the x direction is going to be 180 times 4/5, which is 144. So that's the velocity in the x direction. All right, so I have 144 times t, which I just found was 22.91. So I get that the range here, x sub b, is equal to 3,299 meters, and I'm just going to rewrite this as 3.3 kilometers. So that right there is our answer.